Okay, finally with the quadratic formula, let's take a look at a couple applications. A box with a square base and no top is to be made from a square piece of cardboard by cutting 5-inch squares from each corner and folding up the sides. The box is to hold 1,445 cubic inches. How big a piece of cardboard is needed? All right, the first thing to notice here is this unit is cubic inches, which means they're asking us about volume. So volume is length times width times height, and they're telling us that that needs to be 1445. Now, let's draw a picture and see what the heck they're talking about here. We're starting with a square piece of cardboard. And we don't know how big this is, so we'll call it X by X. And then what they're doing is they're cutting 5-inch squares from each corner. So they're going to cut out the corner, little squares here, 5 inches by 5 inches. All the way around. And then to form the box, these parts are going to be gone. These are going to be cut out. So to form the box, they're taking these flaps and folding them up right along this diagonal. So this is going to end up being the base of your box, the bottom of the box, and you fold this up and this up and this up and this up, and that gives you your 4 sides. Okay, so now dealing with that, what's our length, our width, and our height? Notice this box started length X, and then notice we cut 5 inches off this end, and we cut 5 inches on that end. So the piece here is now X minus 10. Whatever X was, we cut off 5 inches and 5 inches, so we cut off 10 inches total. So we're going to have X minus 10, that's our length. And then I think our width is exactly the same thing, because again, this started a length of X, and we cut 5 off of each end. So that's going to be an X minus 10. The height, when I bend along this dotted line and fold this up, it's going to be that tall, which is 5. Equals 1445. Okay, so actually I don't think we need the quadratic formula here. What I would do instead is I would write this as X minus 10 squared equals, and I would divide both sides by 5. 1445 divided by 5 turns out to be 289. So I don't think this is a quadratic formula problem. I actually think this is a square root problem, because we have this perfect binomial squared. Now, what I will see many students do here, and it's not wrong, what I'll see many students do here is multiply this all out and then bring this 1445 over, and then it does become a quadratic formula problem. But I think that's the hard way. I think leaving this, because these happen to match perfectly, leaving it as a perfect square binomial works better. So X minus 10 equals the square root of 289, I think is a nice number. I think it happens to be 17. I was close. 17. Plus or minus, of course. So X is 10 plus or minus 17. So X is 10 plus 17 is 27. Or X is 10 minus 17 is negative 5. Well, clearly we have to throw that one out. Or it should have been negative 7 to begin with. But we still have to throw it out, because X is a distance. It's the length of the box, length of the original piece of cardboard. Clearly it can't be a negative number, so X has to be 27. Application number 2. An object is thrown upward at a speed of 78 feet per second by a machine from a height of 7 feet off the ground. The height h of the object after t seconds can be found using the equation height equals negative 16t squared plus 78t plus 7. Now you might notice a couple of these numbers showed up in the words here. 7 was the original distance, 7 goes there. 78 was the original speed, the 78 happens to be there. This negative 16 comes from the force due to gravity. The force due to gravity is negative 32 feet per second squared. Negative 32 divided by 2 gives you the negative 16. Why all that works is beyond the scope of this class. Someday, if you happen to take a calculus class, I'll teach you all about that. We will actually figure out the formula for height of an object. But today, you'll be given the formula. Here's the formula. And the question is, when will the object be 28 feet off the ground? Well, 28 feet is h, so they're telling us plug 28 in right there. 28 equals negative 16t squared plus 78t plus 7. We notice we have a quadratic equation because we have a t squared. To solve quadratic equations, we generally want 0 on one side, so I'm going to subtract that 28. So negative 16t squared plus 78t minus 7 minus 28 should be negative 19, negative 21. Good thing I used my calculator and checked. Alright, well now I have two choices. Three choices actually. Number one, I can try to factor. With that being a negative 16, that's not a good idea. Option number two, I could complete the square, which means I'd have to divide everything by negative 16, which is going to give me lots of ugly fractions. Don't like that idea either. Option number three, use the quadratic formula. That's certainly what I would do here. T equals, I'm not going to write out the quadratic formula, I'll just say it as I go. Negative b, that's negative 78, plus or minus the square root of b squared, so that's 78 squared, minus 4 times a, which is negative 16, times c, which is negative 21, all divided by 2a. 2 times negative 16 is negative 32. So t is negative 78 plus or minus, grabbing my calculator, 78 squared minus 4 times negative 16 times negative 21. I got 4740, which I'm guessing is not going to be a nice number when I do it square root. So there's my answer, but that's not a very satisfying answer. In an application like this, I think it makes sense to work this out and get a decimal. So t is, I'm going to do negative 78 plus the square root of 4740, and then divide the whole thing by negative 32. So 0.28 seconds, or 0.29 I guess. And t is, and then do the other one, negative 78 minus the square root of 4740 divided by negative 32, 4.59. So I think in an application problem, I want to know how long it took for the ball to get to 28 feet high. I think it makes perfectly good sense to give decimal answers. And it makes sense here that there are two answers, because the ball started at 78 feet, or I'm sorry, the ball started at 7 feet, went up to 28. So what happened is the ball went up, hit 28 feet on the way up in 0.29 seconds, went way up in the air, and then came back down and hit 28 feet on the way down at 4.59 seconds. All right, question B, when does the object hit the ground? Question B is actually slightly easier because the object hits the ground when its height is 0. So I'm just going to plug 0 in for h, negative 16t squared plus 78t plus 7. And again, I go ahead and I solve, and again I would solve using the quadratic formula. So t is negative 78 plus or minus the square root of 78 squared minus 4 times negative 16 times 7, all divided by negative 32. That's negative 78 plus or minus square root of, calculator time, 78 squared minus 4 times negative 16 times 7, 6532, all over negative 32. So t is negative 78 plus the square root of 6532 divided by negative 32. That one's negative 0.09. Or t is, cheating. Instead of typing that all over, use the second enter button to get that back. Change the plus to a minus, divide by negative 32, 4.96 seconds. All right, in this case, the negative answer doesn't make any sense. We can't have negative time. The ball was launched starting at time 0, so we can't go backward. Which again makes sense, because the ball started 7 feet in the air, or the object, whatever it was. It went up, came back down, it hit the ground at 4.96 seconds.